The next is the system. The system to measure these fundamental and derived quantities. So in books there is directly they have given international system of units. So in book they have given international system of units. This is also called SI system. System international. So before going to system international, there are also other system, like for example I would like to write its name. There are other systems like the first one is CGS. So there are many systems. So the first one is, we call it CGS. CGS. This system is also called Gaussian system. Not important for eta, but for eta important for other entities. So in CGS system they have given C means centimeter, so length is measured in centimeter, where G is gram, that is used for measuring mass, so gram. So in CGS system we use centimeter to measure length, gram to measure mass, and the next is second. So in second is used to measure time. So this was our first system called CGS system. There are also another system that we call it MKS system, where MKS, where M mean meter, K mean kilogram, and S mean second. So we call it MKS system. So meter is used to measure the length, kilogram is used to measure the mass, and second is used to measure the time. So this was MKS system. We have another system that we call it FPS system. So in this system, this is also called foot, pound, second. F mean foot, P mean pound, S mean second. So in this system, length is measured in foot, pound for mass, and second for time. So different system, 1, 2, 3, different system provide different units to measure the length, mass, and time. So the fourth one system is called system international, that instead of these three quantities, length, mass, time, that provides us the unit for 7 physical quantities, and those 7 physical quantities are length, mass, time, and electric current are I. Next is temperature, amount of substance, and the next is luminous intensity. So the system international provides unit meter per length, and for mass they provide the unit kilogram, and for second, and for time they provide unit of second, and for current they provide units of ampere. The next, for temperature, system international unit is Kelvin. For amount of substance they use the unit mole, and for luminous intensity they use CD, which means candela. So this was system international. Now the SI units are mass, kilogram, second, ampere. Now for derived quantities we will use this unit. For example, if area is made of length multiplied by length, so in SI system the length is in mass, so meter multiplied by meter is equal to meter square. So meter square is the unit of area. Now for in case of volume is equal to length multiply by length. So in this case meter multiply by meter, so we will get the unit of meter cube. And so this process continue in case of work, power, acceleration, or any other derived quantity. So this was system international. Instead of fundamental or basic units in derived, there is third unit, or there is third quantities, and this quantities is called supplementary units. This is called supplementary units, that are neither fundamental or neither derived quantities. So in supplementary quantities and in supplementary units there are two units which we call it radian and steradian. Radian is used to measure 2D angle. Steradian is used to measure XYZ or 3D angle. So now discuss the radian and steradian. Now to measure angle we use the unit degree. We use the unit degree. But the SI units or System International Unit provides a unit per instead of degree they use the unit radian. So radian is that angle which is subtended at the center of the circle. So if this is the circle, so 1 radian is that angle when this distance s is equal to radius of the circle. When s is equal to radius of the circle, then this angle or theta will be equal to 1 radian. So theta is equal to 1 radian. Now we also know that in full circle we have 2 pi radian, or we also know that it is equal to 360 degree. So 1 radian will be equal to 360 divided by 2 pi, and that is equal to 57.3 degree. So bear in mind this equation that 1 radian is equal to 57.36, 57.3 degree. Now for steradian, steradian is that unit SR, which mean steradian. So steradian is the angle subtended at the center of the, instead of circle we use steradian for sphere. Sphere mean 3D object while circle is 2D. So steradian is defined as the solid angle subtended at the center of sphere by an area of its surface equal to the square of the radius of that sphere. So if we have sphere like this, this is the area of which made angle at center this like the area of cone. So a cone make an angle at the center theta. So if we draw this thing we will get is like this. So this is theta and this is area. If this area is equal to, so the solid angle is the center of the sphere by area of its surface equal to the square of the radius. So this is radius. So if this area is equal to square of the radius, then angle will be equal to 1 steradian. Now we know that the surface area of a closed surface is equal to, area of closed surface is equal to 4 pi r square. So according to the definition of steradian, the solid angle subtended by a closed sphere at center is 4 pi r square divided by r square. So the area of a sphere is equal to 4 pi r square. So to find the steradian, steradian is equal to area and divided by r square. So here area is equal to 4 pi r square divided by r square. So r square cancel with r, so we will get 4 pi sr. So in one sphere there are 4 pi steradian, while in circle there are 2 pi radian. So 2 pi radian in one circle and there are 4 pi steradian in one sphere. So this was all about System International derived quantities, and the next topic is SI prefixes.